Evidence-based teaching is best based on triangulation. Rather than look at individual studies which may not be representative of all the studies done, we trust systematic reviews of all quality research written by experts. There are two main sources of such reviews. Bottom left on the diagram are reviews of research using effect sizes, like the note-making experiment I described earlier. There are 96,000 such studies summarized in 1,600 research reviews involving 300 million students on different teaching methods. This is a vast database. It has been brilliantly summarized by Professor John Hattie in his Visible Learning, a synthesis of over 800 meta-analyses relating to achievement. Top of the diagram are reviews of cognitive science research, and that's similarly voluminous and just as important. We can use cognitive science principles to analyse and so improve our teaching. Lastly, bottom right in my diagram, there is research on what expert teachers do. An expert teacher is defined as one who creates an exceptionally large improvement in achievement with their students. There is much less of this sort of research, unfortunately. Okay, note-making. It has a high effect size. It follows most cognitive science principles. And expert teachers use note-making instead of giving students teacher-written notes. So note-making is recommended by all three corners of the research triangle. This makes note-making an evidence-based teaching method. That's the good news. But evidence-based teaching does not predict easy and certain success. Its promise is only revealed by your hard work. The most important research is your own experience with the method. I will say more about this in the next video, but you must try an evidence-based teaching method at least 5 times to discover whether it will work for you and your students. Only you can discover if the method will fit well with the way that you work. If it doesn't work for you, there are plenty of other evidence-based teaching methods to try. It takes about 25 trials and improvements of your use of the method for you to begin to be proficient in it and start to release its full power. Even then, you can get better and there is more improvement in attainment to discover. Using evidence-based teaching methods is a very skilled and creative challenge. But it is enormously rewarding to see your students learn better and to think of the difference that you're making to their lives. Also, these methods are usually fun for you and your students. They are really motivating. That's why they improve learning. Professor John Hattie has looked very carefully at effect sizes and finds that teaching methods have more effect on how well students learn than anything else we can change. Some teaching methods can almost double the rate at which students learn, and any teacher could use at least some of these methods and so become an outstanding teacher. Professor John Hattie is well famous for collecting research review evidence to help us to determine which factors have the greatest effect on student achievement. His Visible Learning books summarize his work and they're highly recommended. Here are some of his average effect sizes. An effect size of 0.4 is normal, is average. 0.6 is high. We will study all of these in later videos. Medal and mission feedback, effect size 0.66. A strategy to integrate with prior knowledge, effect size 0.93. Mastery learning, graphic organizers, note making, slightly lower effect size than the others, but still good. Challenging goals, rehearsal and memorization, spaced practice. So all of these methods are worth you trying in your classroom. For comparison, different types of testing only has an effect size of 0.12, and coaching students in test taking only 0.3. The teacher talking to the class has a low effect size too. Most high-performance teaching methods require the student to be active. High effect sizes do not promise certain success. They are very approximate measures and only show what has been achieved by teachers when they have developed real skill in the use of that method. Most of the research summarised by Hattie has been done in Western countries. This may be another reason not to take the effect sizes too literally, as the control group might be slightly different. However, high effect sizes are the only way we have that can roughly sort teaching methods and strategies to determine which have been the most powerful in other people's classrooms. This helps us to decide which methods to experiment with. We can't experiment with everything. We have cognitive science and expert teacher research too to help confirm what is worth trying. So it makes sense to experiment with the best methods, the methods that research has found to be most powerful. How does your teaching skill improve over your career? Anders Ericsson reviewed research on expertise. He wanted to know why some people get expert and highly effective while others do not. His research included many domains of human activity, for example, playing music, playing chess, touch typing, mathematics, and so on. He found most people's skill level plateaus after a few years. They learn very quickly at first when everything is new. We say they are on a steep learning curve. But eventually they find a way of performing a skill that works, and so they continue to do it that way. Now that seems very reasonable. But if you always use the same methods as a teacher, you are likely to get the same outcomes for your students. Importantly, Ericsson found that some people don't plateau like this. They continue experimenting with new ways of working, seeking improvement by doing things differently. This attempt to improve by experimentation is called deliberate practice. Most teachers don't do this. They tend to keep teaching the way they've always taught, so they don't do deliberate practice, and so they don't improve much. But what happens if you do use deliberate practice? While you are using a new method for the first time, your skill level may drop a bit, slightly at first, just when you're using that new method. This is why you should experiment with a new method in a short way first, rather than dedicate a whole lesson to an unfamiliar method. Your performance drops because you are out of your comfort zone, but don't worry about this. It's inevitable when you are learning something new. But after a few trials with a new method, you should learn to use it well, and if the method is a good one, your skill improves. Then you try another method, and so on. This creates the wiggly line of improvement on the graph. If the new methods you are experimenting with are highly effective, your teaching is going to improve as soon as you've learned well how to use those methods. Deliberate practice then is deliberately trying something new which is likely to improve your skill. It might be to use a highly effective method or to address your teaching weaknesses. If you continue with this deliberate practice, your teaching skill will improve with time. Of course, you are not using deliberate practice all the time in your teaching. Most of your teaching will be with the methods that you are familiar and comfortable with. You might try deliberate practice for only 5 minutes in a lesson, and you might do this in only a few lessons a week. Eventually, though, you become comfortable with new, highly effective teaching methods, and then begin to experiment with others. How should you practice with new teaching methods? Try the method 5 times or so to decide whether it will work for you and your students. Reflect then and improve after each trial. What didn't go so well? How could you fix that? What went well? Could you make it go even better? After about 25 times, your improvements will mean you are using the method reasonably effectively. Talk with other teachers about your experiments with the method. Research shows that this is vital. You will get ideas for how to improve from them, and hopefully some encouragement. Talk to your students about the method. They might have ideas too. Keep trialing the method until it works, or doesn't. If it works, keep using it often. If it doesn't work, try another method. There are plenty to choose from. Okay, it's time for the test I promised. Which of these statements about evidence-based teaching are true? More than one could be true. Maybe none are true. I won't read the methods out, but please pause the video to give yourself time to answer. Here are the answers. Please pause the video to study these too. True statements are in red, explanations are in blue. Number 1, not correct. A method is only an evidence-based teaching method if it triangulates. That is, it needs a high effect size and a recommendation from cognitive science, and preferably one from research on expert teachers, but there isn't much of this. 2, correct. Note-making is an evidence-based teaching method. 3, correct. We learn and remember what we have thought hard about. 4, not correct. Note-making does require students to improve their notes during the peer check and during the teacher check. There are lots of evidence-based teaching methods in my book and in my other videos. Used skillfully, these methods make your job easier. They're more fun, they're less tiring than conventional teaching methods. It is best to learn these new methods a few at a time, discussing your trials with colleagues in supported experiments. The easiest methods to start with might be the ones in the 4th video called Starting a New Topic. You can make a real difference to your students if you learn to use these methods well. Some students will succeed where they would have failed. Then they might go on to get higher qualifications they would never have got if not for you. Go on to get a career, a life they would not have had if not for you. Teachers touch lives forever. In many ways, we create the human world and can help our students preserve the natural one. So let's get our teaching right. Thank you for your time. Best of luck while you learn to teach even better and improve the life chances of your students. Thank you.